Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Alhamdulillah, in this video I would like to show you how we make I would like to continue from our previous video session where I've shown you how I make assembly in the bottom parts of this glass suction cup mount holder. So inshallah in this video I will show you the continue session of this from the previous video, so which I will show you how to make assembly on the top parts. So our top assembly here. So as shown in this image here, we have so we have these components for our top part assembly. So we have a right gear connector, left gear connector, we have middle gear connector, we have bolts, a cap, a spring, compression spring, a screw for this mounting plate, and we have a mid slot, and we have two knobs here. Okay. So this view for the top part assembly. So this is another view. Okay, this is another view. So we have an assembly of the top parts. So inshallah in this video I will show you how we make an assembly for the top parts. So as usual, we open our SolidWorks. In SolidWorks, when we open a new document, so we go for assembly, then we click OK. So when we open a new file for our assembly, initially we got to insert our main component first. Before that, let me show you the image for our assembly. Since at the bottom here we have two casing, left gear connector and right gear connector. So I will use this at the bottom here, our right gear connector as our base component. So this will be our first component in our assembly. Okay, the first thing to what I should do, I should insert our component. The first component will be our right gear connector. So this is our right gear connector. Okay, since this is our base component, so we don't click it on the screen, so we simply click OK. So this base component will be put into the origin point of the SolidWorks assembly file. So the next thing to do, we insert all the other component. The next component will be our left gear connector. So let me check. We have a left gear connector here. So I put it somewhere around here. So until we get all this, insert all the component as shown in this image. Okay, we have all this component. We will insert all this component. So in this video session I will not show you the compression spring, so I will show you during the assembly process. So I will show how we create a new file called compression spring, so it will it can be nicely fitted into the assembly. Okay, so we got to insert the other components. Okay, after I've inserted, firstly my first step is I insert only 3 components first, the 3 components that are relevant to our initial assembly. So these 3 components, let me do some assembly first for these 3 components. Okay, after we have insert these three components, so let me do some assembly. So since our my first is right gear connector here is my base component. So what we will do is that we go to mate, then we select these spaces. Okay, these spaces of this left gear connector, and this one is right. So automatically the SolidWorks will put it into coincident. Coincident means that the plane, the bottom surface will be on the same plane. Okay, will be on the same plane. So then we set it first. So the next our mate setting will be, I select this face, vertical face of this left gear connector, and this vertical face of this right gear connector. So SolidWorks will set it automatically to coincident. So but one more thing that we need to do is we got to click at the flip mate assignment here, or we can click anti align here. Okay, what I will do is I click at flip mate alignment. So then both of these components will share the same plane, the horizontal plane and vertical plane. Okay, and this component is already flipped into the right position. Okay. Then I click OK. So my next setting is if I select this cylindrical surface here, and the surface of our right gear connector here. So automatically it will set, make sure it will in concentric mode. Then we click OK. So our two component here is assembled. Okay, it's assembled into the right position. So the next thing to do is we select this middle gear cutter, this middle gear connector, and we put it into the right position. Okay, now I select for this middle gear, I select this ball surface and this cylindrical surface, and make sure that it is in concentric mode. Okay, so it will share the same axis center point there. Okay, then I click OK. Okay, then the next thing, when we zoom in, so we have here is our this middle gear connector. We have external teeth there. So but in our casing here, our right gear connector, we have internal teeth there, we have internal gear there. So we got to mate this gear teeth to the right position there. So what I will do for this middle gear cutter, I will select this point. In my case I select this, not the edges, select the vertex here, the point. So this the point here is at the peak, it's not at the bottom of the gear, at the peak point here. This peak point here will be made if we zoom closely to this gear. So let's put it I put it at this point, so it will be in this vertex. So automatically it will put into coincident, so the gear will be in the right position there. Okay. Okay, let me go to isometric view. So I just want to check whether am I satisfied with this kind of position, or alright, it seems like this position is good enough. Okay, so we click OK. Then let's go back to isometric view. So our middle gear connector in made with the this both component. Okay, the next thing is since in this image we have another component here. Okay, we have another component like mount plate. We already assembled these three components. So we have I would like to show you first how this spring will be put inside the ball. Yeah, so this picture is not that clear to show you. So it will fit inside between these two, inside these two casing here, the left and the right gear connector. So I got to insert this. Since I haven't made this spring yet, so I will show you how we create a new file. Just this is another approach of doing assembly. Sometimes not necessary you have to finish all the components. Maybe certain components like compression spring here, you can do it later on after the assembly to make sure that our components nicely fit in the assembly. Okay, to show you how I do that, so in these three components here, if I go to section view, okay, if I click button here for section view, if I go for right plane, then I click OK. So now we have our section view of these three components. Okay, if you look closely at this part here, so this is a casing for our right gear connector, this one is for our left gear connector. So what I want to show you is that our spring will be fitted into this area. We have a bore, internal bore here, so it will be fitted into this area. So it will be nicely fit into this area. Since the spring will be kind of compressed, it is a compression spring. So in the assembly, okay. So in order for us to do, since I haven't made this spring yet, so the first thing what I should do, since we need the spring to be nicely mounted between this surface until this surface here. Okay, so this surface also, what in this assembly what I should do is that this assembly we have a tab button, the evaluate button here. So what we do is we go to measure first. We need to know the length. We need to know the length of this from this point. We can select this endpoint, not that endpoint, so I do it again. Let me clear this thing. This vertex here, this vertex to this point here. So the distance that SolidWorks shows us that the distance is 8.5, as shown here. The distance is 8.5 mm. So it means that we can create our spring. The length of our compression spring will be 8.5 mm. And another thing that we should measure is okay, another thing, if I go to measure again, the length is 8.5. Another thing is the radius of our, if we measure the edges here, so the radius shown here is 4 mm. Is 4 mm, or the diameter of our spring should be 8 mm or less. So it will be nicely fit into this bore area here. So the diameter of the spring should be at least not more than 8 mm the diameter, and the length should be not more than 8.5 mm. So what I will do then, I will go to a new file here. We open a new part. We open a new part file. Okay. Then we will do the spring, the compression spring. So this compression spring, what I will show you how I do it. So in the front plane, I will not use helix command for the. What I will do is I use sweeps. In the front plane, I make it active. So in this front plane, I go to normal view. So I do some line here. This line is for me to make the path of our compression spring. Let me drag it somewhere around here. So the line, okay. So I put the dimension to make sure that the dimension of my line is 8.5. 8.5. I will not do 8.5 in this case. I will do 8. Okay, 8 mm. I will explain to you later. 8 mm. So 8 mm is our compression spring path line to make our compression spring. So click OK. So I have one line here. So let me exit here. Then another I add another more front in the front plane, another sketch plane there. At this sketch plane, I will make the wire diameter of the spring by using circle. Let me go to normal view. Let me zoom closely. So carefully we, from this point that I put it, a circle there, and put a dimension on the wire of the spring. The wire diameter of the spring is I put it 0.5 millimeter for the wire thickness. Okay, since we have the length here is 8, so we have another section is 0.25 here, and at the top part 0.25, so the total length will be 8.5. So I put the dimension, since our radius is 4 millimeter, so I put the dimension, radius of our spring is 4, so from this point to this point it will be 4 millimeter. So since the diameter of the spring is 8 millimeter, so the radius is 4. Okay, the radius is 4. So then we have another, the cross section for our profile for our spring. Okay, to do spring, then I exit the plane. Okay, I exit the plane. Then the next thing to do is on the features we have a swept boss base here. Okay, so since this cross section is already selected, so it's in here. So for the next settings here for the path, so I select this line. Okay, I select this line. Okay, when we do sweep, so this is our path, so this is our cross section. We have some option that I use the option for twist along path. Okay, twist along path. So the next setting is defined not by degrees, so defined by how many turns. Okay, so in this case, let me put it let's say about 8 turns. So it will show you preview there about 8 turns. Okay, we have a revolution there. Okay, then we have our cross sections. It will do kind of helical spring. Okay, there's another approach for you to do helical spring. Okay. Okay, let's stay on. We stay on with 8 turns. Then I click OK, and now we have our compression spring there. Okay. So another thing to do is that before we put this component into the assembly, so we need to, so this path, this center line is meant for the sweep, so we got to add on the front plane or the right plane, we add another sketch plane. Okay, this sketch plane I make it normal view. So this sketch plane is for us to do the axis for the spring. So if I go to center line, make sure that the axis is in the center as this origin point, but the starting point is coincident with this quadrant, the bottom plane of the spring. So I start at a point, then I zoom out, until the axis here coincident with this top plane of the spring. Make sure that we on the right line here. Okay, make sure it's snap, make sure that it's in vertical. Okay, then we click OK. So this center line will become the axis of our spring. So this axis will be used for our mate setting in our assembly. So then let me check the dimension here. The dimension of this axis is 8.5, since we have 8 plus 0.25 of the radius of the wire, so the total length is 8.5, right? So I don't have to put dimension here, just to check. So our total length of our spring is 8.5. So now we have our spring. Okay, we have our spring. Let me save this component as spring for gear connector. Let me put it gear connector 2, since I have the original file. Spring for gear connector 2. Okay, now we have our file. Then let me close this part modeling. Okay, now in our assembly mode here, okay, in our assembly mode here, let me insert, we go to assembly, we insert, okay, I got to browse again, spring for gear connector 2. Let me put it somewhere around here. Okay, let me, okay, since we have inserted this spring component here, okay, so this portion, this kind of, since we have turned on the section view, so we have our spring have been in section view. Okay, so if I off the section view, so our spring is there. Okay, okay, then let me on again the section view. So let me click OK. Okay, let me put it, let me on again my session view to adjust the, so that we can okay, let me off first the session view. Okay, let me make it into position first, then later on I can on my session view again. Okay, what after we have inserted our we have insert this spring component, then we go to made. So since in our spring file we have a axis here, we can use this axis. Okay, this axis as our made selection. Then we select the ball here. Okay, make sure that it's not in coincident, make sure it's in concentric, so that it will share the same center point there. Okay, then we click OK. Okay, now let me on my section view. If I click OK first, then I on my section view so that I can nicely fit the spring inside. Okay, let me on the section view. Okay, now we have our spring in initial position here. So we need to put this spring inside this area here, internal area here. So what I can do is that if I click at made, I can select this endpoint, or either this endpoint here of the spring, and this surface here, internal surface here. So it will put into coincident, so the spring will be directly into the position. So we have our spring there. Okay, we have our spring. Okay, click OK. Then now we have spring there. So then let me off the section view. Now I have the component of the assembly of 4 components. Let me save my file. Let me call it top assembly tutorial 1. Okay. Okay, then since in this image we have another component. We already have 1, 2, 3, 4. We have another more. We have bolts here. We have all the other components left, and then we got to insert in this. I got to insert. We got bolt. We have bolt here. Okay, let me continue. I make it short. I already insert 3 components. So in this video session, since my computer, my laptop is taking memory, so I will do it part by part. So I insert only the relevant component first in our next assembly. So this our bolt, this our control knob here. So and this our cap for the casing here. Okay, we have a cap. So the first thing what I should do is we have other control knob there. This control knob will be in the position in this position, okay, will be mount on the surface. Okay, so let me go for mate, then I select this surface, and this surface. So make sure it's not in coincident. We set it first into okay, let me go okay, let me undo it again. I redo it. I select the, instead of that face, let me put it this cylindrical surface, or the internal, the ball surface there, and the ball surface here. Okay, make it into concentric. Before we go to concentric, then we got to click on the flip mate alignment, so in the right, so the knob here would be in the right position. Then I click OK. So the next mate setting will be this face and this face. We set it to coincident. Okay, then we click OK. So the knob is there, so the knob is in position. Okay, the next thing, the next component will be the bolt. Okay, the bolt here. So the bolt, since the bolt same as spring, I already done the bolt here with axis. Okay, we select the bolt axis here, the bolt axis, and we can use either the ball here or this surface. Make sure it is not in coincident, make sure in concentric. Okay, make sure in concentric, so that the bolt will share the same axis point there. Okay, then we also must make sure that since if you look on the orientation of this bolt, the surface of this bolt of the hexagon, the bolt head, this surface, and the surface of the ball of this control knob is not it's not parallel. So let me click OK first. The next setting will be we select the face of this bolt. Okay, make sure that okay, we select the face of this bolt, this face of this bolt head, and the face of this hexagon ball here. Okay, make sure that it's in a parallel position, and we click OK. So the next mate setting will be sorry guys, my laptop is very slow. It's all, it's not even i3. Okay, we select our next settings, this face. Okay, this face and this face of the control knob, then we go to coincident. Okay, so the bolt is in right position. Okay, the bolt is in right position. So okay, the next component will be our cap here. We have a cap. Okay, we have a cap. Let's click OK first, so that it will not undo everything. Okay, I click make it again, then I select the cylindrical surface of this cap and the cylindrical surface of this casing. Make sure in concentric. Okay, concentric. Since the cap is facing the wrong direction, I must make sure that we click on the flip mate alignment, then we click OK. So the next mate setting, we select the face of the cap, this cap and this face, so it will directly put into this position. Okay, then we click OK. Okay, I think we have assemble this component. We click OK first. Okay, let me go to isometric view. Let me save this assembly file. Okay, since it looks like our component is in the right position, but we got to check. This is a method of checking. If I go to section view, then if I click OK here, I think we have some issue here. Okay, we have some issue here. So the issue is that in this section view, it seems like our we have the bolt is an external thread. The thread of this bolt is not in mesh with the internal thread of this control knob. So if you look, you zoom closely, it looks like there is some kind of cutout here or intersection here. The bolt thread and the internal thread of this control knob is not matched. So we need to do some adjustment here. Okay, since I've already set the surface of the bolt have been set parallel to the surface of this bore of this hexagon, so I cannot drag the bolt. Okay, so I need to check again my mate setting here. If I go for on this surface, if I select this surface, this bolt, if you click at this bolt under mates in our top assembly, we have a parallel setting there. We have our parallel there. We have parallel setting for our mate. This face and this face is in parallel mode. So I need to delete this. I need to delete that setting. Okay, so I got to do some adjustments. So if the setting of this mate already been deleted, so it means that I can rotate my my bolt. If I move it slightly, our bolt into this position in this section view. Okay, in this position in our section view, it seems like the thread of this bolt nicely made with the internal thread of the control knob there. So in this position, it looks like if I off my section view here, so since we have slightly adjust our bolt, then we go to section view, click OK just to check. Just to check to make sure whether there will be interference there inside this. Let me pan it. Okay, it seems that we have put the bolt into the we have slightly moved the bolt into the right position, so we don't have any issue here where there will be some cutout here. Okay, So this one way to do it. I think I would suggest that the best way you open back your part file. For this case is your control knob where you have your internal thread. So when I did this part modeling for this control knob, so I use this bolt to be cut out by using subtract. So we have my internal thread. So you look at the location of your bolt, which face mesh, which face, the orientation of your bolt when you do the cutout subtraction in your part file, in your component file. So it seems that my approach here is okay. Then let me off the section view. So I think the bolt is in right position and orientation, so we have our bolt component is attached there. Okay, we have our component here. Okay, let me save first my assembly file. Okay, so the next component, the next component will be as shown in this image. We have another component like the mid slot here. We have another control knob there. We have a mount plate and another bolt here to be attached, to be assembled in this top assembly. Okay, let me off this. Let's go back to our assembly file. Right. Okay, then we got to insert another component. Okay, after we inserted all the component here, so we have bolt, mid slot, we have screw for this mount plate, and we have another control knob here. This control is the same. Okay, so first thing what we should do is for this mid slot to be attached here, so we do another mate here. So this we have this mid slot. This mid slot will nicely fit into this two slot here. So I got to select the face of this mid slot and the face bottom surface here, the bottom surface there. So it will put directly into coincident position. It means if you look and from this view, it will be in the same plane there. Let me click OK first. Let me click OK. Then another setting for our mate is we select the bore of this mid slot, and the bore, carefully select the one. Let me delete it. Let me undo it again. This, since we have this face already in coincident position, we select the bore, this bore and that face. So the mid slot would be so it's in the right position. It's, make sure it to be in concentric, so it's share the same center point. Okay, then we click OK. Then we click OK. Then we can simply drag this mid slot here. We can drag it around since we don't have any constraint there. But in this assembly, we need to just want to make the assembly look nice in our assembly drawing, in 2D drawing, orthographic. So we need to put the slot into same alignment with this mid slot here. So we need to put our mid slot here same alignment with our gear, middle gear connector here. So initially this slot is in an angle position, so we need to make it straight. One way to make it straight, so you can set another constraint here. One way to do it is I can select the faces of these faces, this face of this second part here, and the faces the vertical faces there of our gear connector. So we can set to just ignore this. We just select make it parallel. Once in parallel mode, so if we look from the top view, it will be a nice straight line. It will be in line with the middle gear connector. Okay, then we click OK. Alright, let's go to isometric view, and I save first this. Okay, let me click OK for mate setting, then let me save this file. So okay, our next mate setting will be we have bolt there. If you look, we have bolt. The bolt will go pass through here. Okay, if I zoom it, closely, so what we need to do is we select we have axis for this bolt, so I select the axis of this bolt, and we can select the cylindrical surface here. Okay, cylindrical surface there. Oh, sorry, I didn't click at mate first. We click at mate first. Select the axis of this bolt and this cylindrical surface. Make sure it's go into concentric. Okay, concentric, so that the bolt in the right position there. Okay, the bolt in the right position. Just to make sure again that another thing to check is that it looks like our bolt hexagon head and the hexagon bore of our mid slot is in the same orientation. Okay, in the same orientation. So let me click OK first. So our mate setting will be this space. Let me zoom it. I select this space, and the bottom face of the bolt head, so the bolt is attached to the nicely fit into this mid slot. Okay, so we have the bolt there, and we have, then we should put our control knob here. Okay, let me click OK first. Okay, the next thing, we have our control knob. Then we go to mate again, and we select the bore surface of this control knob, and we carefully select the bore of this. I can use this cylindrical surface here. Okay, so then make sure that in a concentric. Okay, so it seems like the knob is in the right direction. So, and also in the concentric, it means same center point there. Okay, right. So then I click OK first. So the next mate setting will be, okay, this face and this face should be in coincident. Then we click OK. Right, so we have our almost finished assembly. Okay, we have our knob there, and we have our, okay, what's left is these two components. Since just to remind, I would like to remind that this, let me click OK first. We got to check whether this knob thread here is in the right, same approach as before. where we need to check whether the thread of this internal thread of this knob is in the right, is really made in the bolt external thread. So when I go to section view, okay, it seems that our knob is not in the our internal thread of this control knob is not in the really a position where it's really the external thread and internal thread. We have some issue here. If you look, they have some intersection cut out there. So we need to adjust, same approach as before. We need to slightly adjust which position of this control knob that we should adjust. So I make it short in this video after some slightly rotational movement of this knob. So it seems like the thread is nicely fit into the internal with the nicely made with the internal thread of this control knobs. Okay, so let me off the section view. So we have our control knob there. So and then we have okay, the next what's left is let me go to isometric view. Let me go to isometric view. So the next thing is our mount plate. Okay, our mount plate. So we click to mate. We click mate, then we go for, okay, we can select this cylindrical object here. So then with this cylindrical object here, so automatically it will set to concentric, but we got to click flip mate alignment. Okay, we flip mate alignment, then I click and I click OK. Then so it seems like we got to push a little bit this mounting plate to the side. Okay, so we can do another mate setting, so it will be nicely fit there. Since we want this ensemble to be accurate, so I select the face of this hexagon and the surface of this hexagon. Make sure that it's go to coincident. I click OK. This surface and this surface here of the mid slot. So I think it should be I think we are in the right position here, right, as the mount plate in the right position there. So this is our correction. Sorry for that. Okay, so mount plate is in the right position, then I click OK. Alright, then I off my, let me save the file first. Sorry guys, I think this video session is the longest one that I've made. It takes, I think, about, already we passed 1 hour limit. Sorry for your patience. Now we have be patient guys, okay. Now is our setting for our screw. Okay, so we go to mate, then we select we can select the cylindrical surface of the screw, the cylindrical surface of the screw. Okay, and we can select the I can use this cylindrical surface. So make sure in concentric, okay, concentric position. We click OK first, then we select the another way is this top face here of the screw and this top surface here, so the screw will be nicely fit into the position. Alhamdulillah, I think we have almost fully done, since this video has passing 1 hour limit and your passion for watching this video. So the purpose of me doing this video was just to guide you guys for doing part modeling. So my approach is not the best solution, so I think you guys have better solution for doing this. I think this video is meant only for as a reference for you guys to do your assembly, modeling, and also assembly in SolidWorks. So I think I try to make it short. Maybe if we click the same issue as shown previously in this knob, the issue between the thread of the screw and the internal thread of this component, this slot component. So we got to adjust a little bit the screw position so that there's no issue of the external thread and the internal thread being intersect to each other. I think I end up this video for this top assembly until this point. Okay, we have previously I've shown you the bottom assembly. So this is part assembly of our project. Okay, Alhamdulillah, we managed to finish our top assembly. We managed to assemble all the components here for our top assembly. Alhamdulillah. So I think you guys inshallah can do even better than me. So I will be seeing you guys on the next video session for our full assembly. Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. See you guys in the next video session. Thank you very much.